So I'm Samantha Radford from the chemistry department, and I'm here to discuss with you how POGIL can benefit your students. We all want effective teaching, and we want our students to retain material. POGIL has worked for me for the past couple years, so I want to share it with you. So POGIL stands for Process-Oriented Guided Inquiry Learning. If you were to ask students from a POGIL course what it is, they would probably just tell you something like, oh, it's a lot of group work. We work together every day. But there's really a lot more to it than that, and that's what I want to explain. So the first part is the process-oriented component. This is about the students learning together. So instead of the classroom being a hierarchy where the professor hands down information, it's a community. So the students work together, and then the instructor is there for guidance and clarity. The second piece is the guided inquiry component. So this is an example of guided inquiry where I'm asking students about isotopes. I never define the word isotope for them. Instead, I show them these two pictures of hydrogen atoms, and I ask them to tell me what an isotope is based on the information. If you're not familiar with POGIL, it might seem strange or different, maybe even too hard to you, but it really isn't. So POGIL has a proven track record for over 20 years. It's now used by over 1,000 people across the United States and the world, both in high schools and in colleges. And there was a group that set out a while back to show that POGIL is more effective than traditional lecture. So they have 7 years of data where they set students randomly either into traditional lecture or into POGIL. And so as you can see, grades went up for POGIL, and there's also less D's, F's, and withdrawals there. Another group wanted to show that POGIL improved student retention of material. So what happened here was students were randomly put into either a traditional POGIL or a traditional section of Organic Chemistry 1 or a POGIL section. So they took the course, finished out the semester, registered for Organic Chemistry 2. At the beginning of Organic Chemistry 2, they took a pretest over last year's information. So you can see here that 60% of the lecture students remembered less than half of the material, while almost a quarter of the POGIL students remembered 90 to 100% of the material. So that's just a huge difference. So POGIL not only focuses on retention of material, but also on process skills that help students in the job market. The first of these 7 process skills is teamwork. Because of the depth of the material, students have to be able to work together in order to solve problems. The second process skill is communication, both written and oral. So here's examples where I had students talk about states of matter, and you can see one group definitely used more communication than the other, and so I point that out to them. And as you can see by my ideas surveys, the students recognize the gains that they get over the semester in their communication skills. The next process skill is information processing, both from prose and from graphs and tables. So before, when I used lecture, I would very rarely use graphs and tables. And when I did, I would explain them really thoroughly first. Now, I give them to them really frequently, and I let them tease out information on their own. The next process skills are problem solving and critical thinking. So this example is about naming alkanes, but we also do a lot of math in my class. In previous years, I would do an example on the board for them before I would let them do anything. But now I let them do things on their own, and I just stand back amazed at what they can do without me guiding them. The next one is assessment. So students will write their answers on the board, and so then once we get to a certain point, we'll all look together at the answers to see what's right and what's wrong. So this gives students a chance to assess, and gives me a chance to see what muddy reasoning there is and how I can help them and clarify. The last process skill is metacognition. So we want students to be able to extend concepts from one type of problem to another. Here I ask them to use dimensional analysis about a gas mileage question, but then the next thing I ask them is how can you use this skill set in other types of problems? Often when instructors first hear about POGIL, they're kind of skeptical. They want to know if you can cover all the information. This data shows, yes, they can. So this is from SFU. We have POGIL and lecture sections of human chemistry and quantitative analysis, and you can see their scores are very similar. All right, the other thing is people were concerned that students won't like it. Again, that's not true either. They might be intimidated, but they feel like they have to study less because it's easier to retain material. And also, 64% of my human chem students said that they would pick this again if they had the choice. So your question might be, could I use POGIL? I use it every day. You don't have to use it every day. Even if you don't strictly do POGIL, just think about, am I asking students questions or am I just telling them stuff? So this is for forensic science. This is a critical thinking question rather than just telling them, no, we don't always know. Here at St. Francis, we've started a community of practice for POGIL. So we're coming together to be able to get implementation tips from each other, to write materials or to, modify these materials, and to connect each other to resources outside of St. Francis. One of the best resources that there is the POGIL website, pogil.org. So again, they have implementation tips. There's also classroom activities that have already been made and thoroughly tested, from years in different classrooms. They have groups for specific disciplines if you're interested, so you can check out that website. So this is a very brief description of POGIL. If you're interested, which I hope you are, you can either contact me or you can contact Teresa and we can let you know more about it. And one of us will be sending you an email soon about our next meeting for the community of practice. So thank you.
All right, good afternoon. I'm Wagner. While she's getting started, I'll get a few extra words in. I think I have too many words. I tend to do that. I know I have too much animation, so bear with me. We're going to see how this goes. I don't think it's going to be quite as graceful as Samantha's beautiful presentation. Here we go. I'm going to talk about energy, which is something I'm immensely interested in, redox chemistry, and how those two have come together for me with a love of bacteria. So I'm going to start by talking a little bit about energy, and we're going to agree upon the statement that energy can neither be created nor can it be destroyed. And so what we're talking about in terms here of my research is conversion of energy. So here we've got combustion, we've got the energy inherent in wood being converted into heat and light. When we consume food, we're converting the energy in the sugars and carbohydrates. Oh, that's a little ahead, a little fast. Into chemical energy. Okay, next slide. That guy's disappearing, but there's my cute little bacteria eating a hamburger. Okay, so we like to eat food that we recognize like a hamburger, but bacteria are willing to go along and eat a lot more than just a delicious hamburger. Okay, things got a little hairy, like I said, keep going. That's where we are, right there. Okay, well, they'll eat a lot of different kinds of wastewater, okay? They'll eat food industry wastewater. They'll eat wastewaters from livestock, from farming industry. And bacteria will also eat wastewaters from our municipal wastewater treatment plants. And so this is a municipal wastewater treatment plant. And there's organic matter in there that the bacteria are able to consume. So when we eat food, I like to think of that food as having a high potential energy, like the top of a waterfall. And the food, the carbohydrates in there, get converted to carbon dioxide, which has less potential energy. Bacteria will also do this, only they can, as I said, consume food that's not only like a sandwich, but also like wastewater. There they are. Okay, we can keep moving. Okay, sorry about my terrible timing here. That's okay. All right. So we have energy in municipal wastewater in the form of organic matter that the bacteria are happy to consume as food, but that energy is not available to us for our economic system. We can't plug our appliances into it. We can't use it to fuel our cars. So what I want to figure out is how can we get that organic matter energy converted into an energy that's useful for the human economy. And so I'm going to introduce you to the work that I do on a technology called microbial fuel cells. And these systems have been converting those wasted carbohydrates that are in our wastewaters into electricity. This research has been really happening in the current era since about 2004. So back to our waterfall. We've got food, it's got high potential energy. We've got carbon dioxide, with lower potential energy. And we have these bacteria that are able to use that food. But what's really going on here is a movement of electrons. So there's electrons in the carbohydrates, in the food, and we transfer them to other compounds. In a microbial fuel cell, we interrupt that cycle. Basically, we stick an anode in here, and we say to the bacteria, you know what, you can have the top half of the waterfall, but we're going to get the bottom half. We put in an anode. It's something like a piece of graphite that bacteria like to live on, and that is conductive. So now the electrons, they go from the food. The bacteria get a little bit of energy out of them. They can do the things bacteria like to do. And then they are deposited on the anode, and we can gather those electrons now in a circuit, and we can generate an electrical current. That's what electrons in a circuit are. They're nothing more than an electrical current. So I've been talking about redox chemistry, but I've really only been talking about half of the process. The process I've been talking about is oxidation, the movement of electrons from carbohydrates out of carbohydrates so that we form carbon dioxide. The other part's reduction. I've added these two things here, oxygen and water, and when you complete that circuit, then you can generate some energy, and you have a complete oxidation reduction or redox process. Okay, next. All right, so I'm going to sum all this up here. Here's my little bacteria. Oh, we got to slow this down. He's got his little hamburger. Oh, why is this happening? Can we turn off the, it shouldn't go automatically.
Well, we can make that happen. Well, it's going to be on automatic timer.
Looks cool.
Hang on.
I told you my animations. Ugh.
That's all mysteries. Let's try it this way.
That's cool.
I'll try it from here.
Okay, this should work. It is cool, but it's not really appropriate for Pachacooch, I'm afraid. Okay, so our little bacteria. He's going to eat, go ahead. He's going to eat his waste burger. Okay, that's his waste material in our wastewaters and convert it to carbon dioxide. Doing so also generates electrons. Now this bacteria's got to figure out, what am I going to do with these electrons? Okay, in natural systems, the electrons are deposited or transferred to oxygen, and oxygen is reduced to water. But in a microbial fuel cell, we've got those same electrons from the food, except in this case, the bacteria gives it to an anode, and now, because the anode is connected in sequence through a circuit to a cathode, the electrons can travel through that circuit, and when you have electrons in a circuit, you've got an electrical current. Now, at the cathode, we're doing the same water production. We're converting oxygen through a reduction process to water, but we're generating electrical current. So, I always put a light bulb in when I talk about microbial fuel cells. But the truth is that I've actually never lit a light bulb with a microbial fuel cell until literally 3 hours ago.
Oh,
wow. Highlights here. I have a student working on some of the energy conversion processes out of a microbial fuel cell. Because, in all honesty, we don't get a lot of energy from a microbial fuel cell. The voltages are quite low, half a volt. To get an LED to light, you've got to have basically 2 volts. All right? So this is a big deal to get a light bulb to light. So we do things like put microbial fuel cells in parallel so we can increase the current. But some of the real benefits of an MFC are that all that waste material, the energy inherent in our wastewaters, it's free. Right now we are spending literally billions of dollars to convert that organic matter into carbon dioxide so that we don't pollute our rivers and streams. Now, MFCs are not going to be the silver bullet that we convert all of our fossil fuel energy from out of our energy system into microbial fuel cells. But when we think about renewable energies in the future, nobody thinks it's going to be just one thing. And so microbial fuel cells might be fitting in about right here, about 0.5% of our United States energy picture. One more thing, go ahead, that MFCs can do is you have these electrons in a circuit. I've talked to you about the reduction reaction of oxygen to water, but you can do other interesting chemical reactions at the cathode, and there are lots of scientists who just focus here. We've got this free source of electrons. They're not very powerful, but what else can we do with them? All right, and with that, I will thank you for your patience with my crazy animation, and thank you for your time.
Kara Kobal from Physical Therapy, and this is my colleague Kurt Kindel. And we're here to talk to you today about the use of videos in a lab-based classroom setting. So we're obviously from health sciences, but we think that our technology has implications for other disciplines as well. So just to give you kind of a little background on the subject, on the topic, our typical lab structure is that we would demonstrate a skill and then we would break up into groups and have the students go and practice that skill. We do have a 12-to-1 ratio mandated for our accreditation in labs, so we have multiple faculty members in labs. But some of the challenges with lab is that it really is, even with the increased faculty, it really is difficult to see what everybody's doing. This is what our lab looks like. The students really get to see us demonstrate the skill one time and then they move on to practice. And sometimes we don't always have time to go back and demonstrate that skill again. And so the challenge really becomes, how can I see everyone and how can I make sure that everyone is practicing the information correctly? So what I started thinking was, how can I do a better job with trying to see everyone in class, and how can I make sure that everyone is practicing, not only practicing, but practicing correctly? How can I have eyes where I don't have eyes, right? And so we started to think about, like any good idea, when you get a good idea, you call the CETL, right? So Bree, you know, I brought the light bulb, she helped me turn it on. I called Bree, we talked about, you can actually use YouTube to upload videos to Blackboard. And so the students have to use their smartphone for that, but you can see Bree and I, we do use landlines, so that's it. So on my first try, what did I do? Basically on my first try, I taught the class, I demonstrated the skills. I split the students up into groups, and I let them practice, and then I had them capture different skill sets, and then I had them upload it to Blackboard. Before they uploaded it, they did have to get instructor approval, so we made sure what they were uploading uploading correctly. So essentially what we did was we created an archive of the skills that we had taught in class that day. They upload the video to YouTube, they put it on there as an unlisted video, so other people aren't going to be able to find it unless they have the URL for it. And so we were able to allow the students to go back at a later time and check their work and make sure they were practicing correctly. So the feedback from the students on this was, wow, this is really great. We should do this in the DPT 1 year. I teach in the DPT 2 year. So a lot of the students were saying, I wish we would have done it last year. So that's where I went to my colleague, Kurt Kindel, and we sat down and started to share my idea and started to talk about what I was doing in the classroom. So as you can see, Kurt and I then began to collaborate. And it was about an hour or so later, and we were still collaborating because we all know that Kurt can talk.
And it was about 2 hours later as we're still talking, and I was really interested. I was really involved. I think at some point Kara got a little bit fatigued with it. But just to let you know, I teach gait. So what is gait? Well, it's the mechanics and science of walking. And so I need to get our students to understand how to analyze it, how to appreciate it, how to observe it. And so, you know, some problems on my end are, how can I get students proficient at this? And so my difficulty is, do I have to go out and get 300, 500, 1,000 people to walk through our lab over and over and over again so that they can learn the different mechanics of gait? Well, that'd be pretty difficult to do. So what I've been doing the past couple of years, probably 3 or 4, is I've gone to my friend YouTube. And it's just, I pull stuff off YouTube, they pull stuff off YouTube, and it has worked, but it hasn't worked well. Because you know what's on YouTube. There aren't good camera angles, there aren't what I want. Sometimes there's people actually already analyzing gait and giving them the answers, which I don't want them to have. So my thought is, I want them to go out and capture, with someone's permission, right? But they're going to capture each other or people on campus or whatever, and more or less create a library of gait videos in which they've gone in and then they do the same thing that Kara had. They upload them to Blackboard. I'm checking them. They're allowing students to see them. You can go ahead. And so the student response was, wow, this is great. Number one, we get to go and do it. We get to upload it. We get to look at all of our peers, all of our colleagues' videos and everything like that. Plus it gives me a library to have that I can kind of say, hey, each year I can start to build this. And this is the first year I've done it, so we'll see how that goes. But the one thing I guess I just wanted to communicate today is the power of video. I think we all know this quote, a picture is worth 1,000 words. And I was talking to a colleague just a couple weeks ago, and whenever we go to continuing education conferences, we love video because If a picture is worth 1,000 words, a video is worth 1,000,000, at least in my thought, you know. And for these students, these millennials in this day and age, man, they want to see it. If they want to learn something, they go to YouTube right now anyways. You know, how to fix my sink, YouTube, you know. How to analyze gait, go to YouTube. So they're already using it. We just needed to jump on board. So what are some future plans? Well, we could do things like patient interviews where they're actually conversing with each other. We could do things in which we're explaining assessments, where we're using instructor and peer feedback involved. And we're videotaping this so that we can put it out there for the students. This is the health science side. How can you use it? Arts and letters, sciences, business. We did throw around some note cards there. You know, maybe you have some ideas that you could possibly share with maybe Teresa, and we could get out to you guys, because again, I'm not in your field. Carrie, you want to talk about some other thoughts?
So just some other ideas we had. We could, we haven't done any graded assignments correlated with the videos at this point, but that's always a possibility. A 1-minute paper that you would typically do with a pen and paper. Maybe they could do a 1-minute video and upload that. You could exchange it between classes if you have 2 sections. Maybe you can do one video for the other section. You can exchange it between disciplines if you want to do interdisciplinary. We also thought like a 5-minute point of clarification. Maybe there's an exam question that a lot of people missed and you just want to go back and hit that material again. Do a quick video, upload it to YouTube, or put it on your Blackboard, and then everyone can see it. So we definitely, thank you. So we definitely are looking forward to the ideas that you guys might have if you start using videos in any of your classes. And we also wanted to give a huge shout out to the CETL for always helping us make our ideas even better.
Thanks.